Welcome to today's video, Mastering Time of Flight Calculations with Miss G. So in a time of flight mass spectrometry calculation, we're looking at how one individual ion moves through the flight tube to approach the detector part of the mass spectrometer. Now, all of the calculations will require you to use the same three equations, and while the specific variable being calculated will differ, you are going to need to use these same three equations in one format or another. The most complicated of time of flight mass spectrometry questions may involve the use of two ions, and this is why this first statement here, which says that ions are accelerated to the same kinetic energy, is important. You may need to use one ion to work out the kinetic energy and then use that information, which will be the same for the second ion, to work out a property of said second ion. That isn't what we're being asked to do in this question. In this question, I've chosen to focus on calculating the length of the flight tube, which is one of the more common types of question you will get. The other most common type of question is calculating the time of flight of one particular ion. Now, those are the calculations that I've chosen, A, because they are the most common, and B, because I think they are slightly more straightforward in terms of calculating the length of the flight tube or the time of flight of an ion, compared to working backwards through the process I'm about to show you to calculate the mass or the mass number of a particular ion. So all these questions are set up sort of in the same way. They always seem to give you the equation linking kinetic energy, mass and velocity. And one of the reasons I believe that they do this is because they then very kindly remind you that the mass of the ion in this particular type of calculation needs to be in kilograms. Now that's unusual because in all of the calculations mass values are in grams. Here it needs to be in kilograms, and that's a very nice reminder that AQA provide. In the time of flight mass spectrometer, it goes on to tell us that we are dealing with the 84 krypton plus ion, and the mass number of the ion is going to be important. It tells us that these ions are accelerated to kinetic energy of 4.83 times 10 to the minus 16 joules. So we've been given the kinetic energy, and we've been given the time of flight of the ion as 1.72 times 10 to the minus 5 seconds. We've also been given Avogadro's constant down here, and you'll always be provided with this in any question involving Avogadro's constant. Now, the three equations that we are going to need, including the one that we're provided with, I've written here in pink. So we're going to need to do something with mass, moles and MR. Now, we don't have any information about the moles, and because we're dealing with an individual ion, we're not dealing with the MR here. So what I've then done underneath is written a slightly different variation of this equation, which suits this particular style of question. So we don't have information about the number of moles, but the number of moles is equivalent to the number of particles divided by Avogadro's constant. So I've just swapped out moles and in its place written number of particles over L. The number of particles is going to be 1 because we're dealing with each 84 krypton plus ion. So the number on the top here will always be 1. Avogadro's constant, as I said, will always be given. And then we're going to times that by the mass number of the ion, not the MR, because it's an individual elemental ion. The mass number here is 84. So that's the first equation we're going to need. That's going to allow us to work out the mass. Once we've got the mass, we'll be able to use the kinetic energy and the mass to get the velocity. So from the equation that they provide you with, you're going to have to rearrange this in this particular type of question to get velocity equals. If you were trying to work out the mass of an unknown ion, you would need to rearrange this to get mass equals. But here we need velocity, so I've taken the half over to this side to make it 2 kE. I've then divided through by the m, which is the mass. And then to get it from velocity squared to velocity, I've taken the square root of my 2 kE over m. The third equation we're going to need is speed is distance over time, or velocity is distance over time. So we have to get the mass first in order to then use this equation, which allows us to get velocity. And then once we've got velocity, in this case, because we want to calculate the length of the flight tube, which is the distance that the ion will travel, we're going to do the velocity that we just calculated times by the time of flight, which we were given in the question. So again, you may have to rearrange this differently depending on what you're looking for. If you were wanting to get the time of flight of the ion, for example, it would be distance divided by velocity. Or it may be that you have distance and time, and this is how you work out velocity in a question where you are working backwards as such. So we can also just use the equation in the format that it's been given here on occasion. Now for this particular question, this is the order that I need to do these three different calculation equations in. So I'm going to have a go at doing that now, and I'm going to talk you through what I'm doing in each stage. But for any time of flight calculation, my advice would always be to analyse the information that you're given, highlight some of the key things. I would always be highlighting the fact that mass is in kilograms, because that is an anomaly. I'd then be highlighting the mass number, the kinetic energy, time of flight, or any other key pieces of information that were given, and then I'd be writing out underneath in my working out these three equations, and I'd be rearranging them to make sure that I have got these equations written in the right format. So as soon as I know I want length of the flight tube, I'd rearrange this to get distance. If I want to know the length of the flight tube, I'm going to need velocity and time. I've got time, I don't have velocity. Okay, so I can get velocity by rearranging this equation, 2 kinetic energy over the mass square rooted. I don't have the mass. Okay, I'm going to need to get the mass from here. So these three equations are going to be really useful. So let me show you what I mean. So, got to start by getting the mass of this ion. So as I said, the number of particles will always be 1 because we're dealing with each individual ion moving through the flight tube. I've divided that by Avogadro's constant, and then I've timed it by the mass number of this particular ion, which will always be given to you in this sort of question in this format here. So that's 84. That will give me the mass in grams, and as I've said, we need to convert that into kilograms, and to do that I just need to divide by 1,000. So this is the mass of my 1 krypton ion. Now that I've got the mass of that 1 krypton ion, I can move on to the second equation and use the kinetic energy, which was given to us in the question, and the mass that I have just calculated for the ion in kilograms to work out the velocity of that ion. So that gives me 83,218.4 meters per second. Now a little word on putting these quite long calculations into your calculator. I like to break it down into stages so that I'm not putting everything in one go. So for example, I did this bit first, hit equals, times it by 84, hit equals, divided it by 1,000, hit equals. Some people will be quite happy doing all of that in one go. If you are going to do it in one go, just please take care, make sure you put your brackets in the right place, because calculator errors are a real problem with questions like this, and a reason why lots of students lose marks. It isn't because of their lack of understanding, but rather a calculator error. So my advice would be to break it down into stages. Same here, I did 2 times the kinetic energy divided by the answer that I had on the calculator for my mass. Then I hit equals, then I did the square root of that answer to give me my velocity in meters per second. Now I've got the velocity, we can move on to the final stage, which is working out the length of the flight tube, which is calculated by doing the velocity times the time of flight, which was given to us in the question. That gave me a distance of 1.43 meters, so that is the length of the flight tube, and that is the calculation complete. Now, again, some students will be quite happy merging all of these 3 different equations together. I don't like to do that, which is why I've explained it this way, again, because the more steps I try to do in one go, the more confused I become. Again, in terms of the calculator, the more confused the calculator may become unless you type it in with really careful precision. So my advice, break it down into stages, As with any calculation, always show all of your working out, because for an examiner marking this, if I happen to do a calculator error and get the wrong distance, the wrong length of the flight tube here, I would hope you would agree that it would be really easy for the examiner to look back and see exactly what I've done here in this question. And the more of these you practice, the quicker you will become at doing this. It's only worth 4 marks this particular question. Some of the more complicated ones, where we may need to use 2 ions and work out the kinetic energy of 1 ion to then enable us to calculate a property of a second ion, they could be worth up to 6 marks, but you will get to the point where you know that these are the 3 equations that you need, where you can rearrange them quickly and efficiently, and then these questions will not take as long as they may be taking you at the present moment. So that would be how I would approach all time of flight mass spectrometry calculation questions. If anybody has any queries or anything that I've said in this video is not clear, please do get in touch with me through a YouTube comment or through one of my social media platforms. You can find me on TikTok, Instagram and Facebook, or you could go to my website, missgtutoringandresources.com, and complete an inquiry form on the contact page. That would be another way of contacting me. I'm here to help, so if anything's not clear, please let me know. Thank you so much for watching. I hope you found it helpful.